Hello, welcome again. We are solving GATE 2022 Mechanical Engineering Paper 1. Question number 53 is a schematic of an epicyclic gear train is shown in the figure. Sun gear, gear 1 and planet gear, gear 2 are are external and ring gear, gear 3 is internal. Gear 1, Gear 3 and arm OP are pivoted to the ground at O. Gear 2 is carried on the arm OP via the pivot joint at P and is in mesh with the other two gears. Gear 2 has 20 teeth. Gear 3 has 80 teeth. If gear 1 is kept fixed at 0 rpm, gear 3 rotates at 900 rpm counterclockwise. The magnitude of angular velocity of arm OP is dash rpm in integer. So this is gear 3 having 80 teeth and 900 rpm counterclockwise rotation. This is gear 1. This is gear 2 having 20 teeth. Okay. So now the teeth of gear 3 and gear 2 are given. So we have to find out the teeth of gear 1. As these three gears are in mesh, so their module will be same. So if module is same, then this is R1, radius of gear 1, and this is diameter of gear 2, 2R2, and this R1 plus 2R2 is your R3. As module is same, so it can be written as R1 can be written as T1. This is your T2 and this is your T3. And T2 is given as 40. So T2 is given as 20, so it will be 42 into T2 will be 40 and T3 is given as 80. So T1 will be at 40. So now we have found out the gear number of teeth on gear 1. Okay. Now using tabular method, so these are the action we are taking, and these are the effect of action. Okay, on arm, sun gear, front and gear. So when arm is fixed, suppose arm is fixed and sun gear is given 1 revolution. Okay, so then arm will be having 0. So arm is having 0 revolution and sun gear is given 1 revolution. So as gear 2 and gear 1 are in mesh and these are in external mesh, so the velocity of planet gear 2 will be in the ratio of teeth, because this is having only 1 revolution. Okay, and similarly the ring gear is in internal mesh, so with gear 2, so its direction will not change, and the number of revolution of the gear 2 is T1 by T2, and so the number of revolution of gear 3 will be minus T1 by T2 into T2 by T3. Here sign will not change. Okay, here sign will change, and the revolution will be the ratio of number of teeth, just by equating or by taking that omega 1 by omega 2 is equal to T1 by T2 or T2 by T1, keeping the velocity same, velocity of gear 1 and velocity of gear 2 as same. So we can find out the ratio of angular velocity. Okay, velocity means linear velocity. Okay, now if the arm is fixed and sun gear is given x revolution, just keep it 0 and multiply it by x. Now arm is given also y revolution, so it will be y plus x, y minus x T1 by T2, and y minus T1 by max T1 by T3. Okay, now given that the gear 1 is fixed, so here the angular velocity of the gear 1 is y plus x for, okay, so it is y plus x is 0, and gear 3 is having 900 rpm counterclockwise rotation, so taking it minus, taking counterclockwise as minus, so it will be so this quantity will be y minus x T1 by T3, So this will be y minus x 40 by 80 or minus 900. Okay, so uh, because T1 is 40 and T3 is 80. Here T2 will cancel out. Okay, so now from this equation y plus x is equal to 0 and y minus x by 2 is equal to minus 90 900. Uh, we can find out x subtracting 1 and 2. We can find out 3x by 2 is equal to 900. So x is equal to 600 rpm. Okay, so we are and y will be from this x plus y is equal to 0. Y will be minus 600 rpm. So now we are taking only magnitude. So answer is 600 rpm. Okay, so answer is 600 rpm. Next, under orthogonal cutting condition, a turning operation is carried out on a metallic workpiece at a cutting speed of 4 meter per second. The orthogonal rack angle of the cutting tool is 5 degrees. The uncut chip thickness and width of the cut are 0.2 mm and 3 mm respectively. In this turning operation, the resulting friction angle and shear angle are 45 degree and 25 degree respectively. If the dynamic yield shear strength of the workpiece material under this cutting condition is 1000 MPa, then the cutting force is dash Newton. Round up to 1 dash Newton. Okay. Now here it is given that the shear yield stress is 1000 MPa. 1000 MPa. Okay. And width of the cut is 3 mm. Thickness of the cut is 0.2 mm. Shear angle is 25 degrees. So from the shear stress Wt and shear angle we can have shear force, that is tau s into area project area will be Wt by sin phi. Okay, so Fs will be 1000 into 0.2 into 3 by sin 45. Okay, now if Fs is known, then using that merchant circle, so this is your merchant circle diagram, so this is your Fc, this is Fs, this is Fn, and this is your resultant, this is your F, this is N, this is Ft. So as Fs is the component of R, so the value of R will be Fs divided by cos of this angle, cos lambda minus alpha plus phi. Okay, so this is will be your R, and Fc is also the component of R, so Fc will be R into cos of this angle lambda minus alpha. So from this we can find Fc. So now here the friction angle is given, lambda is your friction angle, alpha is your rack angle, phi is your shear angle. So friction angle is given 45 degree, shear angle is given 25 degree, alpha is rack angle, and rack angle is also given, rack angle is 5 degree. Okay, so putting this value we can find out Fc, that is 2573.40 Newton. Okay, next, a 1 mm thick cylindrical tube 100 mm in diameter is orthogonally turned such as the entire wall thickness of the tube is cut in a single pass. The axial speed of the tool is 1 meter per minute, and the specific cutting energy U of the tube material is 6 joule per mm cube. Neglect the contribution of field force towards power. The power required to carry out this operation is dash kilowatt, round up to 1 decimal. So the power required is specific energy into metal removal rate, and specific energy is 6, and metal removal rate is that is pi dt into velocity or axial speed. Okay, so that is the projected area, or that is axial speed, projected area of cut, and that is axial speed. So d is your 100 mm and t is your 1 mm. Taking these and this is your 1000 by 60. Okay, so power will be your 31.4 kilowatt. No need to change this diameter into meter because J is in joule per mm cube. So answer is 31.4.